All right, this is a video to show you how to do a one proportion test. There are a couple of ways you may find yourself doing a one proportion test. One scenario may be that what you have is summarized data. In other words, some other team or person or process has collected the data and reported back to you how many opportunities there were, and out of those opportunities, how many events or how many defects. And so what you have is a numerator and a denominator. And what you want to do is check to see if those results, that numerator divided by the denominator, is different from some benchmark amount. So here's a scenario we're going to work with. We've been looking at customer satisfaction results over time. Our historical customer satisfaction rate is about 80%, or a proportion of about 0.8, exactly 0.8. And we've got some results back from the latest survey. And in that survey, there were 180 responses, and 151 of those customers said that they were satisfied. So what I want to know is that proportion statistically different from the historical proportion of 0.8. So I'm going to start by opening up the one proportion test. And what I'm telling Minitab here is the default is it opens to having data in a table. Well, I don't have data in a table. I've got summarized data. I've been told that 151 out of 180 customers were satisfied. So what I have is summarized data. So the events, that's the numerator, 151, and the number of trials, that's the denominator. And what I want to know is that proportion statistically different from a historical proportion of 0.8. So for a hypothesis test, the hypothesized proportion is 0.8. Click on OK. So it's doing test and confidence interval for one proportion. Minitab is telling me that the lowercase p represents the event proportion. And we can see there's 180 events, 180 in the denominator, 151 events. That represents a sample proportion of 0.83. You can see the 95% confidence interval around that. So what Minitab is saying is that it's 95% confident that based on this sample of 180, the true proportion of satisfied customers falls somewhere between 0.776 and 0.889. My null hypothesis is that there is no difference in my sample proportion of satisfied customers and the historical proportion of 0.8. So H sub O is P equals 0.8, or there is no difference. The alternative hypothesis is that my sample proportion is not equal to 0.8, that there is a difference in my sample proportion and 0.8. My p-value, the critical statistic here, is 0.194. Remember, our alpha is 0.05. And if our test p-value is above 0.05, it means our p is high. We keep the guy, meaning we fail to reject the null hypothesis. And we cannot say that there is a difference in our sample proportion and the historical proportion of satisfied customers at 0.8. There is no difference. Now, that's using the sample information that some third party gave us about the denominator and the numerator. If we actually have the data, if we actually have the results in a table, then we approach this test a little differently. So I'm going to open a data file, and the data file I'm actually going to use here is the two proportion test data. And you'll see why we're using it. There's two tabs here. It opens to samples in different columns. The other tab is samples in one column. So I'm going to flip to the samples in one column. So what I've got here is my overall results: satisfied, not satisfied, satisfied, not satisfied. You can see on down there, and I've got 180 rows. So rather than using the summarized data that was reported to me, I'm going to use the actual data that I have. So I'm going to go to Stat, Basic Statistics, One Proportion. Now, what it remembers is that last time I did this test, I was using summarized data. I'm changing it up. I'm going to go to one or more samples, each in a column, essentially telling Minitab that my data is in a table. And my data is in the customer satisfied column. Again, I want to see, is there a statistically significant difference in the proportion satisfied from my historical proportion of 0.8. So I got my perform hypothesis test box checked, and the historical value of 0.8. Okay. And of course, it gives me the same results. Again, here the event is where the customer was satisfied. So it's counting in the numerator the rows where the value is satisfied. And P, lowercase p, represents the proportion where the customer satisfied variable equals satisfied. 180 rows, 151 events. My sample proportion is 0.838. You can see the confidence interval around that. My null hypothesis is that there is no difference between my proportion satisfied and the historical proportion. The alternate hypothesis is that there is a difference. And again, I'm using the same underlying data, so my p-value is 0.194. The p is high, keep the guy. We fail to reject the null hypothesis and conclude that there is no difference statistically in my proportion of customers satisfied and the historical proportion of 0.8.